Questions 10 to 14. The decrease in radon concentration in Tony's grandparents' house is an example of exponential decay. Exponential decay can be modeled using an exponential function. In exponential decay, a quantity is multiplied by a constant factor that is greater than 0 but less than 1 during each time period. 10a. The concentration of radon is multiplied by a constant factor for each half-life. What is this constant factor? What are we multiplying each time to go from one half-life to the next? We are multiplying by 1/2. Write an exponential function r of t for the table in item 4 using 400 as the initial concentration of radon and the constant factor from part A. So we would write this. RT equals my initial concentration, which is 400, times 1/2 raised to the T power. Use the function from item 10b to answer questions 11 through 17. Identify the meaning of RT and T, and what are the reasonable domain and range. RT is the amount of radon concentration and this would be in measures of PCIL. T is the number of half-lives our reasonable domain and range are non-negative real numbers. We don't seem to need to know what happened prior to us starting this, half-lives before we started our initial concentration. And it doesn't make sense for us to look at after a concentration goes below 0, which I don't actually think it will. Describe how your answer to item 10a is related to the function RT. Well, my answer to RT is, 10a is 1/2. And how is that related to this function that we wrote for 10b? The 1/2 is the number that is raised to the T power. Graph this function. Okay. And I'm going to change my window whenever I do this. So we're going to go up to y equals. I'm going to clear out my first function that we did earlier. We're going to do 400 times 1 over 2 to the x power, because we got to use x in the calculator. My window, I'm going to change it from 0 to 10. And this is going to be 0 to 400. And those are measurements of 50. And we're going to graph this. So we have here here. And it kind of looks like this. Describe how the original concentration of radon is related to the function and to the graph. Well, in the function, that initial 400 is the number that's multiplied. It is the number multiplied to the power. In the graph, that 400 is my y-intercept. On to the questions that wrap this section up.